Significant figures and calculations. An important point of emphasis up front is that the math in this technique is going to be the same as always. What will be a little bit different is the rounding that occurs, because we'll be using the rules for significant figures. This might be common to see in math class. In fact, you may have even been told that you can just leave off zeros after the decimal point if you'd like. But we know when we're dealing with measured values, digits matter. In the case of 5 meters, only one digit is present. That means it's an estimate, whereas 5.0 has 2 significant digits present. The 5 is known and the 0 was the estimate. A strange thing is happening here. We're starting with a measured value that's very uncertain. 5 was something that was totally an estimate. And we're ending with a product that all of a sudden has 4 significant digits. Knew the 2, knew the 5, knew the first 0, and estimated the final 0. What we're doing here is we're manufacturing certainty. We're starting with an uncertain measurement, and all of a sudden we're creating a very certain product. We're going to take care of this problem by using 2 sets of rules for rounding when doing calculations. One set of rules that applies to multiplication and division, and the other set that applies to addition and subtraction. For multiplication and division, we're looking for the measurement with the fewest sig figs, and we're rounding our final answer to that number of sig figs. In the case that we just looked at, since 5 meters has 1 significant digit, we need to round our final answer to 1 significant digit. Again, to be clear, the math hasn't changed. 5 times 5.0 is still 25. We're simply rounding our final answer to 1 significant digit to take care of the certainty issue. Looking at the 2, which is the first significant digit, looking at the 5, which is immediately to its right, that causes the 2 to increase to a 3, and we're left with 30. Using the Atlantic Pacific rule, we know that the decimal point is absent, so that we're starting from the right side, the Atlantic. Don't start with the 0. 3 is the only significant digit in our final answer. Another example for division. Same approach of determining the final answer, then considering the rounding. If 2.5 has 2 significant digits, we have to round our final answer to 2 significant digits. The rules for addition and subtraction are different. Very important to note that this time we're actually looking for the fewest number of decimal places, and we're rounding our final answer to that number of decimal places. As a for instance, the addition in this problem is the same as always, but at the end we see that 5.2 only has 1 decimal place, so our final answer needs to be rounded to the 10th place using the conventional rules of rounding. In the case of the next example, we've got a whole number in 3 liters, meaning that our final numeric answer will need to be rounded to the whole number. Again, to clarify, using decimal places for addition and subtraction, and the number of significant figures for multiplication and division. A final word on different types of numbers. We've been focusing our attention on measured values, and the significant measured values are all the ones we know in one and only one estimate. But there are exact numbers in this world, and 3 examples are counting numbers, definitions, and abstract numbers. An example of a counting number would be 24 students. If there are 24 students in class, there is no estimate there. There is exactly 24. That's why we say that there are an infinite number of significant digits in a counting number. Another way to write that would be 24.00000000 going on forever. Again, because there is no estimate with a counting number. Another type of exact number would be definitions. There are exactly 100 centimeters in 1 meter because we said so. And abstract numbers, like the ones we use in math class. 2 plus 2 is equal to exactly 4. Because exact numbers have an infinite number of significant digits, we don't factor them in when rounding.